Hey SpaceWatchers! This is Space Cafe Radio, your channel about trends, cool people, and real conferences. My name is Chiara Monter. I'm the event coordinator in our SpaceWatch.Global team. End of January this year, I was able to attend the 14th European Space Conference in Brussels. Here, I had the pleasure of meeting Guenther Hasinger, the Director of Science at ESA. We talked about astronomy, what the Director of Science actually does, and of course the excitement surrounding the James Webb Telescope.
Thank you so much. It's wonderful to have you join us. So you were introduced to me as being very passionate about astronomy and working at ESA, and now what's the connection there? Of course, it's all linked to space, but why is astronomy important?
I have been a space scientist from the very beginning. I was trained at the Max Planck Institute for extraterrestrial physics. That whole institute was created to do space science, and I became an X-ray astronomer. X-ray is basically the very hard energy radiation which can penetrate your bones, and you can still make mirrors out of X-ray telescopes, but you have to impinge the X-ray radiation under very slant angles, and I did my diploma thesis to optimize the reflection of X-rays. And so then I turned into the ROSAT mission. ROSAT was the very first large science mission that Germany did, and I basically was one of the founding members of the ROSAT mission. I did my career by looking at the sky in X-rays. And when you look in X-rays, then you see all the violent events, mainly the black holes and the energetic events in the universe. And so the sky is full of black holes. And so that's the reason why I think all of my career, I'm actually love black holes. I discover black holes. I try to understand how black holes have formed and how they develop and what role they play actually in our existence, because there turns out that very likely the black holes have a much more important role than we believe. So that brought me into space, but that also brought me into astronomy, because you have to, optical astronomy, you have to go, when you discover an X-ray source, you have to go to an optical telescope and see what is there, get the redshift, the distance to the object, and so on. And so that brought me to Hawaii. I was the director of the observatories in Hawaii. And 4 years ago, I came back to Europe, and then I became my dream job, the director of science of ESA. And so I can combine my passion for astronomy with my responsibility for all of space science, and I also learned about comets and planets and the solar system. But my heart is still where the black holes are.
Well, it's wonderful to hear that passion. That's very nice. Maybe a very naive question. What does Director of Science at ESA do? What's your responsibility?
Yes. So, ESA has 10 directorates. Science is one out of those 10. Science is special within ESA because it's a so-called mandatory program. That means every member state has to pay a certain fraction of their budget into the science program, which makes it, on one hand, very stable, so we can plan over very long horizons. We have 25-year planning cycles, and within these 25 years, we roughly know what will be the big missions that will fly in 10 years, in 20 years, even in 30 years. And then we are also announcing missions, announcement of opportunities to the community at a regular pace. We are asking the community to give us their ideas, what is the best way of spending this money now. We have just a competition running right now for 2 future missions. One so-called medium class mission, and one small mission, F-class, flexible, fast mission. And so we are then implementing, using the money from the member states, we are implementing the scientific ambitions of the European scientists. And we are trying to make the European scientists shine, so to speak, as bright as possible. Our current hero is the Gaia mission. Gaia is an astrometry mission which is studying very precisely the location of stars, measuring the same star 100 and more times very precisely. And so we can actually see whether something changes, whether stars are moving. And this is giving us the possibility to measure distances to stars and to measure how the stars in our galaxy are moving. And we can, in a sense, unravel. It's like archaeology. When you are digging into the past, you can unravel the history of our galaxy. So the director of science is more or less the face to the community, and also to the management team and the executive inside. And I'm in a very nice position, so to speak, where I can really, on one hand, see all the new developments, but also shape the new.
Sounds really exciting. And now I'm curious, because especially, at least from what I've learned, I mean, space for sure, but also astronomy especially is such a cross-border discipline because it
Yes.
only works through international cooperation and cross-border collaboration. And is that something that is really in the forefront as well with your work?
Indeed. I mean, I would first say it's an interdisciplinary science in itself, regardless of politics first, because it covers so many different facets here. I think an astronomer is a physicist in a sense with a very, very broad specialization where you need to know a lot about many different factors. But indeed, then astronomy as the most democratic science in the world is also prone for international collaboration, even in difficult times, even when there are political tensions. Astronomers have always, and the space scientists, work together. ESA is set up as an international organization because we have 22 member states, but also cooperation with NASA, with China, with Russia, with Japan is in our genes. So most of our missions are either led by us with international participation or led by a partner agency where we are a small partner. And the most brilliant example is the James Webb Space Telescope, which we have just launched and which is now arrived on final orbit.
That's a perfect transition because that's what I wanted to ask about as well, because I heard that you're very involved in this. And of course, I watched the launch, super exciting. How was this whole process for you?
You know, the James Webb Space Telescope was developed already very early, even before the Hubble Space Telescope was launched. People were already dreaming about a bigger thing. In the beginning, this was at the time when the whole world was thinking you can do everything faster, better, cheaper. And so they have humongously underestimated the complexity and the cost of the mission. But once this has all been settled down and once the 20 years and the $10 billion roughly were spent, it is a fascinating machine. It's the most beautiful and most complex thing that has ever been launched. And Europe is very proud because we have several important roles, not only the launch, which was marvelous and really also allowed to significantly enhance the lifetime of the telescope. We also have built, there are 4 eyes, 4 instruments in the focus, and 1.5 of those instruments are from Europe. And so we have built one, ESA has built one, and another one was built by the European community. And so we are really in the heart of the mission. And we have about 20 people working at the Space Telescope Science Institute in Baltimore for us. So they are integrated into the team. So we are really part of the whole gang.
Perfect. Really nice. And what is your biggest goal with what you want to see come from the James Webb Telescope?
So first, you know that after having arrived at the L2 orbit, we now need to very carefully align all these mirrors. This is not a fundamental problem in itself because we are used to do that on ground. You know, the Keck telescope or other segmented telescopes are doing this every night. But to do it in space for the first time, these mirrors have to move with very, very tiny motions, 1/10,000th of the diameter of a hair is the motion of these mirrors. And then they also have to be shaped so you can actually push and pull on the center of the mirror in order to get it into the right shape. So this will take a few more months. In the meantime, the telescope also needs to cool down to about 40 degrees above absolute zero. And so we are expecting that by the end of June, roughly, we will see the first science images, and then everybody's already very, very exciting. For me personally, one of the most fundamental things that James Webb will do is to look at the very first starlight, because the universe is expanding. Mm-hmm. And the galaxies who are more distant, their light is shifted to the red part of the spectrum, and the most distant galaxy, the light is shifted so much that it is no longer in the visual where we can see with our naked eyes, but it is in the infrared. And so you need to observe in the infrared. And James Webb is the first instrument that can actually make sensitive observations in the infrared because it's cold itself. Infrared is heat. Mm-hmm. And if you want to measure heat, then you need to have a cold telescope. And so we are actually really, for the first time, after the Big Bang, We know that the Big Bang was a very hot fireball. We still see the echo of this fireball in the microwave background radiation. But then there was a period of about 1 billion years or so, which we call the Dark Ages, where we know nothing about. We have never looked at it.
Hey, yeah.
And so it's almost like when you go back in history, this is roughly the Dark Ages, the medieval Dark Ages, where you need to dig into the earth and see what kind of stuff did they have at that time. And we do the same thing in the universe. So we will see the first light of the first stars in the universe. And for me personally, there's a fundamental excitement because in the classical standard scenario, the universe started more or less as this hot fireball, and then it needed a lot of time before all this matter was coagulating to form stars and galaxies. So the first stars probably have been formed about 300, 400 million years after the Big Bang. I actually believe in a theory where the very first thing that was formed by the universe is black holes. So the so-called primordial black holes, which are formed already in the first 2 seconds after the Big Bang. And if that is true, those primordial black holes actually force the stars to form much earlier. So in my theory, we would see stars not 300 million years after the Big Bang, but maybe 50 million years after the Big Bang.
Wow, right.
About factor 5 to 6 further out. Mm-hmm. And that is something that James Webb could probably already see in the very first year of observation. So I'm really very excited about either seeing nothing or seeing 10 times more than expected.
It sounds super exciting. I'm very much looking forward to following this further and to see what will happen. Thank you so much for your time. It was really nice.
It was a pleasure.
Thank you for being on and for explaining all of this. And I think we'll all bite to your fingernails to see what happens.
Thank you very much. It was a pleasure.
Thank you all very much for listening to our Space Cafe Radio. I'm Kara, Event Coordinator at SpaceWatch.Global. And with that, I leave you for today. And don't forget, become a Space Watcher. Bye!